Alright, so we are looking at lesson 14. We're going to look at free body diagrams and then elevator problems. So hopefully after this lesson you will understand how free body diagrams are drawn and you'll understand elevator problems. So my brother-in-law is an engineer, and free body diagrams is how they solve a lot of problems, especially in their engineering classes as they're going through those. So I understand that you may not need the free body diagrams right now. You may be able to do it in your head, but as the problems get more complicated, you're going to want to have them. So this is a very basic concept that you may feel like is unnecessary, but I really want you to get in the habit of drawing them, because later in physics, later in other physics classes, if you take them, you will definitely need to be able to do them. So the weight of the body, weight is mass times gravity, is always going to act straight down, and it's caused by the pull of the gravity on the body. So your weight is always going straight down towards the ground, towards the earth. Acceleration of a body is caused by the sum of the forces that are acting on the body. The reaction forces are not considered because they do not act on the body. So we only look at the ones that are acting on the body. So let's look at an example here. We have an object whose mass is 10 kilograms and it's hauled upward by a rope. The tension in the rope is 240 newtons. What is the magnitude of the acceleration of the object? So this is the formula we're going to use, and it may be a formula you want to write down on your formula sheet. T equals mg plus ma. So T is tension, m is mass, g is from gravity, m again is mass, and then a is acceleration. So those are your variables. So we know the tension is 240, and they tell us the mass is 10. And gravity is 9.81. And then we want to find the acceleration. And so that's your formula you're going to use, but we want to actually have a picture drawn to give us that formula. So I'm going to go over the little drawing. Here is our object. It's hauled upward by a rope, and the tension in the rope is right here, and then the weight is pulling down here. But it's being pushed up this direction. It's going in the positive direction. So whatever the tension is minus the weight is going to equal the amount that is going up, which is the mass times the acceleration. And your weight is mass times gravity. And so if you add that to both sides of your equation, whoops, that's where this equation comes from. So that's where your free body diagram is coming in. Tension is going this way. The weight is pulling down, always down to the ground. And it says it's hauled upward, so that means that our acceleration has to be going up. Okay, so we're going to do 240 equals 98.1 plus 10a, and then 240 minus 98.1 is 141.9, and if you divide by 10, you get 14.19. And how many sig figs should we have in our final answer? You should have 2, so we're going to have 14, and acceleration is meters per second squared. And so that's how you can work through that problem. We're going to look at another one. A man whose mass is 80 kilograms is standing on a scale in an elevator. So we have our elevator, and we have our man standing here. And it has initial upward velocity, so we're going up. And what is the apparent weight of the man indicated by the scale? So the weight is always pushing down, and there's a tension on the rope that's pulling the elevator up. So the formula that we would get from here, the tension minus the weight is going to equal the mass times acceleration of what's going up, the force that's going up. You remember that F equals ma? So this is your force that's going up. And if you add your weight, which is mass times gravity, over, you get to this formula here. So we want to know what is the apparent weight of the man indicated by the scale. So our mass is 80 and gravity is 9.81. Mass again is 80 and our acceleration is 2. Now what about this velocity of 3? Do we need velocity anywhere in this formula? No, they just gave it to you to confuse you. So sometimes they will give you information that you don't need. Sometimes it is information that you need. And then we're looking for the weight, the force that's indicated by the scale. So all you're going to do is multiply and add those together. And I get 944.8. And how many sig figs are we going to have in our answer? Hopefully you said 2. So we're going to have 940 and then newtons for your units. Okay, so that's how you can do an elevator problem. We're going to look at another one. The same 80 kilogram man is in an elevator that is now going down. So, and with an initial velocity of 5 and accelerating upward at 2 meters per second. What is the apparent weight of the man indicated by the scale? So again, we have our man, but it's accelerating upward. And this is pulling up and the weight is pulling down. So this is our mass times acceleration, our force, and this is our tension, or our force that's pulling up. And so we're going to be looking for the weight of the man, which is our force that's pulled up. The mass is 80. The gravity is still 9.81. The mass again is 80, and the acceleration is 2. So if you multiply and add, you should get 944.8. And so we have 2 sig figs again, so 940. So what is different about this problem compared to the last one? The only difference is the initial velocity, but the initial velocity is not considered in this part. So the apparent weight of the man doesn't get changed by what the initial velocity was. It's only changed by the acceleration at the time that we're looking at. So we don't have to worry about what the initial velocity was in either problem. So that's why you get the same answer. Okay, so now we're going to look at another example. We have a woman. Downward velocity was that. She was accelerating downward, so her acceleration is going to be going down. And there's a tension on the rope that's pulling her up, but her weight is going down. So the tension minus the weight equals the mass times the acceleration. And this is going to be a negative number. And so when we go into our formula, we're going to put -3 because that's going to indicate that it was going down. And our mass was 56. Okay, and so then you're just going to plug in and solve. And I get 381.36. And how many sig figs do we have in our answer? should have 3, so it's going to be 381 and newtons. Okay, so thinking about an elevator real quickly, hopefully y'all have all been in one. If you were going down, all of a sudden the floor is going to drop out from under you, and real quick you're going to feel like you weigh less on a scale, which is what happened here. Her force is going to be less than what her actual weight was. If you do 56 times 9.81, you get 549, and so 381 is obviously less than 549 because she was going down. The scale got a relief for just a second. And if you're going up, like in this example or the second example, then 80 times 9.81 is only 784, but his force on the scale was 940 because when it started going up, the floor pushed up into him a little bit more, and so it had a higher force on the scale. So that's how you can kind of work through elevator problems. They're not terribly difficult, you just have to kind of think about them a little bit. So your homework tonight is 1 through 20, so make sure y'all do those so that we can go over any questions you have tomorrow.